Welcome to part 2 of our volumetric analysis tutorial. For a second there I forgot exactly what I was doing, but here we go. So we are going to right now go through and do calculations on the mean titer. Now first of all, let's go through and actually talk about what on earth are we talking about. Well, the mean titer, mean is a fancy name for average. So I want to work out the average height of the people in the class. I would go through and I'd actually get all the different heights of the people. I would measure them all and then we go, okay, let's say I add them all up and it ends up being a certain number. Then I go, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 people in the class in total. So I'd go the total divided by the number of people there were. So I've added up all the heights divided by the number of people there were, and that will equal the mean. Great. As you know, we've gone through and done a titration. Okay, on the previous page we saw the titration like that there, and here are some pretend numbers. We've simplified these numbers somewhat, which is awesome. We've got 12.6 mils. That was the amount that came out of, there's a little tap there, it came out of the burette, and it was 12.6 mils the first time I did it. Excellent. Second time 13, next time 13.1, after that 12.9. Okay, what I do is I go through and add them up and then divide it by 3. You may be thinking to yourself, wait a minute, there's 4 numbers up there. Notice that very first one, that first one there was not the same as the rest. It was way off what the rest of them are. All these 3 numbers here are basically plus or minus of this middle number. Okay, so what we basically said is, well, that one there was probably wrong then. I did something wrong there. It is an outlier. It doesn't fit the numbers. So I'm taking the 3 good numbers and I'm only using them, assuming that something went wrong with the very first one. Great. So I add up 13.0, 13.1, 12.9 together. Then I divide it by 3 because that's how many there are. Awesome, and that'll give me 13.0 mils. Now, of course, your numbers could actually be something like 11.25 plus 11.50 plus 11. Yeah. Anyway, and so what you do is you look for the ones who are too far off. Okay. Okay. The next one's coming out, and it is 11.20, and then it might be 11.20 mils again, and so I'd go through all of those and go, aha, those are all very similar apart from that one there. It's not necessarily the first one that is the one that is wrong. Excellent. Let's move on. Why do we discard the 12.9? That one, oh actually, yeah, 12.6, sorry, reading? Well, it's because it was an outlier. It was probably wrong somewhere along the way. Okay, excuse me. Let's go through the process of working out the unknown concentration, because that's what we're after here. We know the concentration of one of the solutions, but it's the unknown that we don't know. And we are going to go through and calculate it. First of all, step number 1, we are going to write down a balanced equation. For example, here's a balanced equation right now. Now at level 2, we are going to be using only acid and base reactions, which means it makes a salt and water. Great, let's move on. Write down everything else we know. What sort of volume of liquid was in the pipette? Okay, remember the pipette's that funny bulb type thing? Okay, and normally it's 25 mils. Okay, but it could be ranging from 5 mils right up to 50 mils. Okay, the volume, the mean titer, that's the volume that came out of the burette. Like on the previous page, we calculated it to be 13.0 mils to 1 decimal place. The concentration of the standard solution, okay, I'll just make up a random one here. Remember, the standard solution is a concentration that we know. And also, what was the standard solution? Was it standardized H2SO4, or was it standardized NaOH? let's say in this case here, this random example, I'm going to say that was the standard solution right there, and the unknown concentration was the sulfuric acid. Okay, next one. Number 3, we are going to go through and calculate the amount of the substance that was in the standard solution. So on the previous page, you know how I said the standard solution was sodium hydroxide, and it was like 0.100 moles per litre, and let's say that was the amount that came out of the burette, so it's the titers, therefore it's 13.0 mils. Then what I can do now is I can go through and work out the amount, because the amount is equal to the concentration times the volume. So I'd go 0.100, which is my concentration, times my volume. Now, if right now you're saying, yes, I know what that is, that's 13.0 mils, then you've forgotten one very important thing. You must always convert the milliliters into litres. How do I do that again? Well, 13.0 divided by 1,000, because there are 1,000 mils in a litre, and that will give me 0.0130 litres. Excellent. Let's move on then. I'm getting my calculator out, so I can go through and go, okay, 0.1 times 0.013 equals, and it generates this little number here, 1.30 times 10 to the negative 3. Cool. Or otherwise written as that. And that, of course, is measured in moles. Rightio. Next thing. Oh, what a mess. Now that you know how many moles of the standard solution we used, look at the balanced equation. Would you need more or less of that substance, of the unknown substance? Well, let's go back and look at that thing here. Let's go through and clear the sheet so we actually see what we're doing. Okay, so if I know that I had 0.0013 moles of this, I am going to need, see, there's twice as much sodium hydroxide as there is sulfuric acid. So therefore I need half that amount. So I need 0.0013 divided by 2. That's how much sulfuric acid I will have. That's the amount of sulfuric acid. Cool. And so I go through and plug that into a calculator, divide it by 2 equals, and I end up getting 6.5 times 10 to the negative 4. Excellent. Okay, let's move on. So, if I needed more, then how many more? 2 times more? 3 times more? Okay, if less, how much less? Half as much? Yes, we actually needed half as much of that unknown this time. Okay, some people right now are going, hey, wait a minute, I could actually work out now. I know that the concentration equals the amount of the unknown substance divided by the volume of the unknown substance. So that's that amount I already have. And I know the volume because the volume, in this pretend situation here, was the amount that came out of my pipette. Let's say it was a 25 ml pipette, then we can go through and plug the rest in. Okay, so, oh, by the way, therefore we go through and work out the missing amount. Now, C equals N divided by V, as I said previously. And let's say it was a 25 ml pipette. I've got 6.5 times 10 to the negative 4 moles. And if it was a 25 ml pipette, that will mean it is 0.025 litres divided by 0.025 litres. And that will give me the concentration. Okay, divided by 0.025 equals 0.026 moles per litre. So now I've gone through and I've calculated the unknown substance's concentration. Phew. Okay, Remember, all calculations must be in litres. That's really, really important. And the final value, you must have the following unit, moles per litre, written after it. Okay, here's an example. Okay, the standard solution is in the burette. So let's go through and draw that. Here's my standard solution up here in the burette. And oh look, it's 0.1 moles per litre. Actually what I really should do is put a couple of extra significant figures in there, because that's going to be very accurate. I know what it is too, 3 significant figures. How do I know that? Well, because I went through and made it like that. Okay, unknown concentration is from a 20 mil pipette. So I've got 20 mils down there in the bottom. That's the purple stuff. Notice the colours at the top too? They sort of match. Excellent. Okay, then I go through and I do my titration. Notice the colour changed, my liquid went down, and I've got these values here. Well, I'm going to get rid of that one because that is the outlier. The average titer is that, as we worked out earlier. The amount of NaOH equals C times V, which equals the concentration times the volume, which equals that amount right there. Excellent. Notice I divided it by 1000 to work it out in litres. Rightio. Then I went to my balanced equation and I found out that I've always got twice as much sodium hydroxide, so if I've got to work out the sulfuric acid, it's going to be half the amount. So yep, I go through and divide it by 2, which means I halve it, and I've got this number of moles right there. Okay, therefore the concentration of H2SO4 is this many moles, which I've gone through and calculated, in this many litres. Notice it was 20 mils in the bottom, so 20 divided by 1000, and it ends up generating that number right there. I think I did something wrong on my previous page, or maybe that one there's wrong, who knows. But I think I might have missed off a 0 on the previous page, but anyway, never mind.